Hi, we are from At Home Tuition. In this video, we are going to see few examples on application and identification of inverse proportion. Our first question is, a school has 8 periods a day, each of 45 minutes duration. How long would each period be if the school has 9 periods a day, assuming the number of school hours to be the same? So solution, let's see what's given, what to find, and then we'll see how to do it. So it's given number of periods in a day in a school is 8 and time for each period, that is time for one period is 45 minutes. So total periods is 8, for one period it is 45 minutes. Next, what we want to find is, if the number of periods in a day is 9 instead of 8, so time of each period will be how many minutes? Okay, so the total working hours will be same. So 8 hours means 45 minutes each period. Suppose if it is one period is increased, with the same time we want to find what is the time of each period. So here the number of periods increases, so the duration of each period will decrease. So number is increased, so the time for each period will decrease. So it is an inverse variation or proportion. So if an increase in one quantity decreases the other quantity and vice versa, then the two quantities, let's consider here as x and y, are said to be in inverse proportion. We know the relation for inverse proportion as x into y equal to k, or x equal to 1 by y into k. So where k is a constant. Okay, so now let's consider x as the number of periods and y as the duration, that is time for each period. So now what is given? If number of periods is 8, so we will take x1 as 8 and time for each period, that we will take it as corresponding y1 will be 45 minutes. So now suppose if there are 9 periods, so we will take the number of periods, that is x2 as 9. We want to find time for each period if it is 9 period. So we will take that corresponding value as y2. So now we know the relation for inverse proportion, that is x into y equal to constant. So we can write it as x1 into y1 equal to x2 into y2. So now we are substituting the values. 8 into 45 equal to 9 into y2. On rearranging, we get 8 into 45 divided by 9 is equal to y2. So that is 360 divided by 9. So y2 equal to 40 minutes. So if there are 9 periods, then each period will be 40 minutes long. 8 periods means 45 minutes. So if there are 9 periods, then each period will be 40 minutes long. So period is increased and the time is decreased. So it's an inverse variation or proportion. Now let's see the next example. Take a sheet of paper, fold it as shown in the figure, count the number of parts and area of a part in each case. So tabulate your observations and discuss with your friends. Is it a case of inverse proportion? Why? Okay, so now let's see what's given. So they have given sheet of paper. So this is a square paper. So folding a square sheet of paper in different ways and finding the proportional relation between its area and the number of folded parts is the one what we are going to do. Now let us take this. So now we'll do it in a tabular form, so it's easy for us to do. So now first take a square sheet of paper. So we have number of parts 1 and the number of shaded region is 1. Okay, so now the area of each part will be, so there is a whole, shaded is 1 and the whole part is 1. So 1 by 1, so area will be the full paper. Now we are folding the same square sheet into 2. That is, we are folding it once. So and half of the part is shaded. So we have number of parts is 1, 2. And number of shaded part is 1. So area of the part we will find it as shaded region divided by the total region. So shaded part is 1 divided by total part is 2. So 1 by 2. So area of the shaded part is half of the paper. Next, Next, we'll fold the same square sheet once again. So now if you fold once again, we'll have 4 parts. 1, 2, 3, 4 parts. So on the shaded part, we'll have 1 shaded part here. So now I will find the area of the shaded region. So shaded region divided by total number of parts. Here shaded region is 1 divided by total number of parts is 4. So next, so we are dividing the paper like this into 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. 8 equal parts and only the one of the part is shaded. So number of parts is 8 and number of shaded region is 1. So now how will find area of the shaded region? So shaded region divided by total number of parts. Shaded part is 1 divided by total number of parts is 8. So area is 1 over 8 or 1 by 8. Next, we are dividing the same square sheet into 16 equal parts. So number of parts will be 16 and only one part is shaded. So area of the shaded part will be shaded part divided by total number of parts. So shaded part is 1 divided by total number of parts is 16. So area is 1 divided by 16. Now we'll find the relation. So now let's tabulate the number of parts and area of each part. Okay, area of the shaded region of the each part. If it is 1, the whole paper is shaded, so area is also 1. If number of parts is 2 and one part is shaded, so area will be 1/2. Similarly 4, it is 1 by 4, 8 is 1 by 8 and if number of parts is 16, then area will be 1 by 16. So if you look into the table and if you observe it, number of parts is increasing. At the same time, the area of each shaded part will be proportionately decreasing. So one is increasing, the other one is decreasing. So we know that if an increase in one quantity decreases the other and vice versa, then the two quantities x and y. So here number of parts is x and area of the each shaded part is y. So the two quantities, number of parts and area of each shaded part, are in inverse proportion. So this is the explanation why it is in inverse proportion. So one increases, the other decreases. Now let's see the next example. Take a few containers of different sizes with circular bases. Fill the same amount of water in each container. Note the diameter of each container and the respective height at which the water level stands. Tabulate your observations. Is it a case of inverse proportion? Now let's take 3 different containers, okay, of different sizes, that is different height and different diameter. So now what we are doing, equal amount of water is poured in all the 3 containers. Now let us see how it does. So now here the diameter of the container is D1 and diameter of the second container is D2. So which is, the diameter is more than this diameter. Next container diameter is D3. So which diameter is more than both D1 and D2? It's more larger. So now if you are pouring same amount of water, let's take 1 liter of water if you pour. Since the diameter is less, and let's take the height of the water in the container is as H1. Okay, so now the same 1 liter of water we are pouring in this container. Since the diameter is more, so the height of the water level will be less compared to the first one. So let's take that as H2. Now we are pouring it in the third container. Here the diameter is very large. So if you are pouring same amount of water, 1 liter of water same, so we will have the height of the water level will be very, very less. So let us take that as H3. So here the diameter of 1 is less than 2 and 2 is less than 3. So if you pour equal amount of water in all the containers, the diameter is increasing but the height of the water level is decreasing. So we know that if an increase in one quantity decreases the other quantity or vice versa, then the two quantities x and y are said to be in inverse proportion. Here let's take x as diameter of the container and y as water level of that particular container. So if increase in diameter gives a decrease in the water level. So it's an inverse proportion. Hope you have understood how to identify the inverse proportion. Thank you for watching this video.